and then that's one task done. And then I will just give us a minute or so and we can go live, and I'll start admitting people into the room. Okay, are you happy for me to start admitting people in, James, at this time?
Yeah.
Okay, I'll bring people in.
I'll wait a couple of minutes, or 2 minutes.
Yeah, we'll give it a couple of minutes. Just as people are joining, I'll just let them know for those that are coming in. Okay, good afternoon, everybody, and thank you all for joining us. James and I are just hanging on for a minute or so as we are expecting a few more people to join us, but thank you for arriving just before 12 o'clock. We will get going in just a second. Right. Okay, so as I said, thank you everybody for joining us. There is just one other person arriving, which is typical, really. So my name is Craig Donaldson, and I am the course advisor for our MSc Electrical Power Systems Engineering course. And by now, hopefully most of you have spoken to me with regards to questions around the application process, entry requirements or fees, or just some general questions around your prior qualifications, etc., and work experience. So today, my job is to support James, who will run through a series of slides regarding the course, and I will hand over to James in just a moment. But James and I would like to encourage you to send through your questions that you might have around the application process, or whether you're suitable for the course. And I can pitch these to James at the end of the presentation. So you will notice there is a chat feature. So please do use it. I will keep an eye on it. So just a final point from me before I do hand over to James, that the closing date for applications is Monday the 24th of August. And we have got some further details about who to send your application to in terms of an admissions email address. So we'll get to that towards the end of the presentation. So with that, I think it's probably about time I hand across over to you, James.
Thank you, Craig. And thanks everyone for turning up. So in this webinar, I really wanted to just talk about kind of the course quite generally, kind of what things you'll expect to see, requirements, and I'll give a bit of a background to kind of where it came from. First, a little background about myself. So I'm a senior lecturer in electrical engineering. I'm also the academic lead for pedagogy within kind of broadly across all of science and engineering. So I have a real focus on how to improve the quality of educational materials, which hopefully kind of is reflected in the quality of the course that you see. And back when I did my PhD, I was looking at how you quantify the risks when you've got a system that has a real high penetration of renewable power. So it's a bit of kind of system modeling, a bit of risk analysis, and a bit of stats. But really now I'm focused on my role as course director and pedagogic lead. So trying to get the best out of this course and looking at the whole broad shape of it. But it's not just me. It certainly couldn't be just me. We have a whole team of academics who have contributed to this master's program in some way. Often what we'll get is someone who is an expert in a very kind of niche particular area. So Chang focuses on oils in transformers and kind of assessing the degradation of transformer performance over time. He's produced some recorded material and some of the lecture material on that piece. Mateos looks at high impact, low probability events, kind of big risky events that can occur. We've got people looking at materials, people looking at system design, people looking at power electronics, and all sorts of different areas, and each of them will produce different pieces. And it's great to be working in a team that's so broad and so large that we can have people who really specialize in these different pieces. And in terms of kind of where I see the course or how I see the course fitting, you've got kind of electrical engineering, and that splits into the low power stuff and the high power stuff. All the low power stuff is electronics, and we ignore that side. And in the high power stuff, again, that can be split into generation, thinking about rotating machines, thinking about the mechanics of kind of creating energy or creating useful electricity. And then the actual system side, how once you've got these generators producing the power required somewhere, how do you get it out to all of the people that you need it? How is it used? How do you maintain the system in a suitable way? And that's what we focus on, that systems view. And this includes the components that you'll encounter, sort of what's in a substation, lines and cables, what do loads look like, how do you analyze those systems or those components, what are the kind of main operational concerns of the economics of it, how do you manage a fleet of assets, the reliability, the protection, and then there's a little bit that we do on innovations and future trends. So that's kind of where the course sits broadly, and it is looking at this system level. So think, what's the power system of a country or a large network, rather than something like a house. And then I wanted to talk a little bit about the importance of the power sector. So the power sector is the electrical power sector is huge. And you can see on this chart, so the IEA produces a big kind of yearly or regular update of what's happening in the sector. And these what this graph is changes in investment in different countries, in different areas of power systems. And it's measured in sort of billions and tens of billions here in the swing. So you can see that the US has recently increased their spend by $10 billion, mostly around the network aspect, which is an aspect we really focus on. Whereas India's really been focusing on solar power and wind power. Whereas the countries that like Japan and the European Union, who previously focused on that a few years ago, in sort of early parts of the 2000s, 2010, they're now focusing on that less and switching to other pieces. So there's a lot of change going on. And actually, one of the big reasons for that change is that variable renewables, so wind power, battery storage, solar photovoltaics, are a lot cheaper than they were. And so if we just follow the solar photovoltaics, the solar panels that you'll see on kind of people's houses and in fields, if you compare the price in 2010 and 2018, there is almost an 80% discount. It's 20% of the price that it was. And that's meaning that there's a lot more solar photovoltaics being installed. There's also a lot more battery storage. You're just seeing these exponential increases in these system components. And that's completely changing what a power system looks like. But there's a few, so, in summary for that piece, it's a massive field that's changing a lot, which is really exciting. And I was thinking more broadly about the challenges. I sort of split them down into three areas. On the generation side, there's a lot more happening now, or a lot of the changes that are happening and the new additions are that it's renewable. And those renewables tend to be distributed, so far away from where the power is consumed, which has a load of challenges. It also has challenges because if they're distributed, it's harder to measure, monitor, and control. If you just had a few coal stations to phone up when something's gone wrong or when you need something changing, that's very different to there's now solar panels on everyone's house. It's non-synchronous, and this synchronicity keeps the system frequency the same. If there's a large inertia like there is in traditional fossil plants. And so this rate of change of frequency is going up, and that's a real problem. It's also non-schedulable. You can't tell the wind when to blow. You can't tell a solar panel when to produce power. So there's a whole load of complexity that comes with the new types of generation. In terms of demand, there's in particular areas, there's a big increase in demand. In some areas, there's a reduction because of more efficient uses. So there's a changing pattern in how we're using our power. There's a lot more storage coming onto the system we're not necessarily making best use of at the moment. There's also, I guess, generally a lot more participation. If end users are having electric vehicles, that's a large battery, that's also increased usage. If they've got solar panels, then that they're also producing power. If they've got smart devices like space heating, fridges, etc., then they're acting much more like these much larger traditional power system plants used to, where they're really involved in the markets, involved in the power system as a whole. So that's changing. And then at the system level, that's sort of resulting in more information being available, more control being needed, more automation. Things are, we're getting digital substations. That's increasing cybersecurity risk. There's also increases risks around extreme weather, and it's all requiring an increase in automation and intelligent systems. So there's so much going on, which makes it a really kind of exciting area to be in, I guess. So that's kind of what the field is, kind of why I think it's an interesting area to work in. In terms of what we actually teach, there are 8 taught units, and there's a summary of them here. So the first one, energy systems, mostly just brings people up to speed. So because we get people from different backgrounds and different areas, which we'll talk about later, I want everyone to brush up on the kind of the fundamental electrical circuit analysis, 3-phase per unit, that sort of thing. That they, the sort of things I look for in your prior transcripts to make sure you've done it at some point. But I need to make sure everyone's at the same standard. I also get people starting to do their own research, picking countries and comparing how changes in the countries affect the power systems, sort of getting you ready for master's level study. So there we're talking about the system as a whole. Second unit is analysis. Load flows, faults, modeling of systems, modeling of components. We'll give you a copy of MATLAB and you can kind of jump in and play around with some of that if you want. There's some coursework and some exams there around, how do you analyze components and how do you analyze systems. Then, and some of these units will be taken in different orders. It's the physical plant. So what's a transformer? What's it made of? What does it do? What are the main considerations? What happens to it if you're sticking it somewhere for 40 years? Same thing with lines, same thing with underground cables, same thing with switchgear. So it gives you an idea of what is in a substation. After that, we jump back to from a more sort of practical based or physical based unit into a more theoretical one, the operation and economics. And this is about really about mathematical optimization, because that's what the operation of a power system is. It's how do you keep stability, security, adequacy, etc., whilst optimizing for cost. So a lot of mathematical optimization applied to the markets, the ancillary services, and the planning that is needed for the operation of power systems. Then we're into kind of one of my favorite units, which is smart grids and sustainable energy systems, where we're saying, what's the future? What's coming next? And so there's a little piece in this on the changing face of distribution systems, because that's where we're seeing some of the biggest changes. So it will look, let's say you had this very traditional feeder. What happens if a load of people down there want electric vehicles, they want solar panels? What happens if you're starting to introduce active network management, tap changing transformers, you're forming loop flows rather than linear feeders? And then there's some sort of open-ended courseworks that we give you to think about that. And you start, again, getting you to do some of your own research and literature review there. And then the final two start looking at dynamics. So what happens if things aren't just a nice, simple 50 hertz sine wave? and protection systems, looking at different ways of protecting the system and what's the general scheme there. And then that final unit, again, taught by me. So I sort of topple and tail it with the first and last unit. There, I'm sort of preparing you for a bit of academic work and a bit of business kind of innovation to say, come up with your own innovation within power systems and pitch it to me as if I was an investor. So there we're talking about some of the financial side, some of the ways that innovation occurs within power systems, the places where it happens quicker, the places where it's very stagnant. But that's the shape of the course as a whole. Obviously, there's so much more we could talk about and put in there, but these are the ones that we thought were the key bits. Okay, so those are the sort of the main 8 units. Each of those last a fixed 10 weeks. Now, 4 of those are mostly coursework based, so there'll be a continuous assessment. 4 of those are exam based, where the assessment is loaded up towards the end. As you can take 4 of those in a year, it'll take 2 years to complete the talk component, and then you move on to the dissertation. And this is a big individual project on something that you choose, or is chosen kind of in collaboration with you and a supervisor that I'll assign based on the area you want to work in. And that's your opportunity to really go and do your own thing, to do your own research. And for some people, they're able to do this as part of their job. So we had a guy recently who looks after a substation, and he's sort of expecting that over the next however many years to become a digital substation. So he did a project around, well, what are digital substations? What are the options available? What are the trade-offs of what things are ready to change now, and what things do we really need the technology to stabilize before we start implementing them? And he was able to complete that more quickly than other people would, because it was his job and his sort of study. So that's why I say a minimum of 6 months to do that. But normally people will take a year to do the dissertation. You can take breaks. So if you said, oh, I only want to do 2 or 3 units in a year, that's fine. And it just stretches out your the time that it takes you to do the master's course up to a maximum of 5 years. And in terms of what you actually get when you're there, this is a screenshot of one of the courses, one of the course pages. I think this one's from Smart Grids, split up into 6 different sections. And during that, you'll see videos like we've got in the top left here. Again, this is look at a feeder, how much maximum penetration of electric vehicles that you could get in this particular system or simplified system. But in addition to these, you'll get practice problems, discussion activities with your peers. There'll be academic tutors who'll support you either through email or discussion boards, or these sort of every couple of weeks we'll have live video tutorials, question and answer sessions, interactive sessions. You get access to the library, which means IEEE Explore, load of recommended reading textbooks, and we'll ship you or send you licenses for a load of different pieces of software that are used throughout the course. So that's what you get. And I wanted to talk a little bit about why Manchester. So at the last Research Excellence Framework, 83% of our research was ranked as either world leading or internationally excellent, and 25 Nobel Prize winners have either worked or studied here. So we are a leading and large research intensive university. Last year we were the University of the Year for Graduate Employment, and at the most recent world rankings we are 6th best in the UK and in the top 30 in the world. So Manchester is very good. If you look specifically at the electrical energy and power systems group, this course, they've always had a course running since 1963, and that's probably the longest running power systems course anywhere. There's an incredible legacy that we've got here, and some incredible researchers. That list that I showed you at the start, a number of the professors there have many hundreds of publications, chapters of books, invited speakers, etc., etc. It's great to be working with that team. And the other piece that I think is really kind of a benefit to the course is your peers. So let's go through. We've got obviously your transmission system owner, your distribution network operator, your system operators, the people who own the physical assets. You've got some people who design the assets, so transformer designers, cable designers. You've got people who do design, operation and maintenance of substations, of lines, of cables. You've got a few people who look after fairly complex sites. So someone who was looking after a combined heat, cooling and power system within a large factory. And they had to deal with the protection side, the generation, the distribution. So they were quite interested in that. What else? And we've got then the sort of the large engineering consultancy and engineering management firms. So a nice mix, and it's good to see the conversations that happen between people there. In terms of what we need from you to be able to join, and what you need to be able to sort of succeed in this course, we need the equivalent of at least a 2-1 honours degree. So, and that has to be in something relevant, something like electrical engineering, from a reputable institution. And when I'm going through that, I'll be looking at, well, what is the standing of the place you've studied? What are your taught units? So, you know, I'm expecting to see certainly circuit analysis, certainly engineering mathematics, probably something like control systems, so, electrical power systems, maybe power electronics, those sorts of units at a 2-1 level. But that's the sort of the factors I will take into account. It's an absolute requirement that you need this 2-1 or first honours degree. And I can also factor in industry experience as well. So if you very narrowly miss out on the entrance criteria, there is this modular entry, but it is really for people just on the borderline. So if you're not sure, contact Craig, and he'll either be able to respond or put you in touch with me, and I'll be able to give a bit more detail on that. The other piece is, you know, you have to pay us the fees, and you have to show that you have competency in English language. So that's either a recognised test or that you've studied in one of the approved kind of English language speaking universities. So if you've studied in the UK or the US or a couple of other countries, that's okay. And in terms of then the general requirements, the course is designed so that you have to spend about 15 hours a week studying for 40 weeks a year. You've got to have a computer fast enough to run all the various bits of software, the internet connection stable enough to run the video conferencing. Prior to the epidemic, the coronavirus lockdowns, there were physical exam centres for 4 exams. I'm expecting those to start up again at some point. So you've got to be able to attend those once that's up and running again. Although I'm not sure, I don't think anyone knows the timelines for that. And I think that's me done. If I hand back over to Craig.
Thanks so much, James. And just as I start going through my bullet points, I'd just like to remind everybody, if you do have some questions, I can see some coming through, is there is a chat feature attached to your Zoom portal, so please do send them through and I can come back to them and pitch them to James shortly. So as I mentioned at the start, I am the course advisor, and I think by now I've had conversations with most of you that are attending today. So following on from what James said, please do get in touch with me if you're unsure around your suitability, and I can take a look at your transcripts and take a look at what I know James would expect to see in your transcripts and kind of guide you of what to put in your personal statements, to demonstrate your work experience that you've got, so that James can see it when he comes to look at your application form. Some key information from the slide that you can see there. I've highlighted the second email address, which is the applications. That's where you should be sending your application, sorry. And that's to our admissions team. A lot of times I get sent through to the study online, which is my email address. But really where you can CC me in, but where you need to be sending it to is the worldwide applications. And I will share these slides with you all again, so you have got it. The closing date, as you can see, is Monday the 24th of August, but do try and get it in before then so that James has got a chance to take a look at your application form, supporting documents as well. So what James will be looking for there is that you are sending your up-to-date CV, which gives him some information on obviously your work experience, your roles and responsibilities, but probably most important is your degree certificates and also full transcripts as well, which I think in the past, James, you've probably received part transcripts maybe along the way.
Yeah. I mean, this is probably one of the most common things we come back to applicants and say, I need to see every unit that you studied at your undergraduate for every year, the title of it, how many kind of hours of study or credits or whatever it was, and your grade. Every university will supply this as an official document, and that's what I need. That's the main thing I'll be judging as the piece of evidence for your kind of competency.
Yeah. So yeah, please do send them through to me, and I can take a look at them and offer some guidance as well. And if I'm unable to answer, I'll certainly get you in contact with James as well. Okay, so that's the part from me. I can see some questions coming through, James. I've also got some here from people who were unable to attend today, but I will just take a look in the chat. Have you got sight of this as well, James? Just so you can
Yeah.
So the first one.
Okay, so the first one, yes. Does the February deadline have the same application deadline? No, so we have 2 intakes a year. One, the closing date is this Monday, the 24th of August, and the start date will be, I think it is the 7th of September. So they'll be processing your application, some inductions, and then getting you added to the system so that you're all up and running for that date. But there's another application in sort of February time, and Craig will be sending out the details of kind of when the closing date is for that. But it's normally roughly a month before or something like that.
That's right, James. I'll come back to that once I've got an idea of the dates. I'll just take a look now.
Yeah. But yeah, if you want to go for the February entry instead, you'd need your application in probably sometime in January, but I don't know the date off the top of my head.
So it would be typically around the 22nd of January, which is Friday the 22nd, but I think admissions may accept up to around Sunday the 24th, which then gives James kind of the last bit of time to look across.
Next question was around the equity and merit scholarship. Yes, so the university do offer a limited number of scholarships for people from certain countries or from certain backgrounds. I think the best place to go if you're interested in that is first check the details about the equity and merit scholarship at the university website, and then probably get in contact with Craig if that's something you're interested in. Yeah.
There's been one question come through to me privately, I think, but it will be okay to mention it to you in front of the group, James. It's from Michael again. Hopefully we'll understand what he means, but does the course cover data centers also?
Yeah. So we have a couple of people, or have had a couple of people on the program who are responsible for the electrical system in a data center. It's not the primary focus of the course. There is no specific teaching about data centers, but there's a number of things that at least this person who worked in a data center thought was relevant. So the protection aspects, the general aspects about power system analysis, about dynamics, and sort of reliability are very much relevant, even if they're not targeted to data centers. We're normally looking at large systems as a whole. Some of the other units, like economics and operation, there we're really looking at kind of what happens if you've got people owning different assets within a system. So that would be less relevant. But it's never possible to find something that's exactly right. But what I'd suggest is looking through each of the units and working out how much is relevant to your particular role. We do sometimes get people who kind of come from a building services background and are more doing electrical installations of low voltage systems. And in general, this just isn't the right course for them. Really, I'd expect you to be involved with a fairly complex system that involves the configuration of maybe protection devices, substations, multiple feeders. But that might be at all the components that sit within that. But it's up to you. If you have the entrance requirements and you want to apply, sometimes I have a chat with people and say, look, is this the right course for you? But feel free to sort of put that in and we can have a chat.
We'll go from there. Yeah.
I
think the next one is from
someone from industry. Is there a requirement to have a reference from my line manager as well as university? Okay. We generally require at least one reference. And it's not absolutely required. So if it's very hard to get, stick everything else in with only one reference. And if we need the other one, we can come back to you and say, look, we need this. Although if you're looking for the application by the 24th, really try and get everything in as soon as possible, because if we have to come back to you, we're going to miss that deadline. If, let's say, you got a first honours degree in electrical engineering with a real focus on power systems, then I'm not going to worry too much about what your industry says about you, because you've absolutely passed on the academic stuff. Whereas, I'll still check you've got one reference to double check that, but put in what you can. And if we do need to, we'll come back to you. It's been more than 5 years since I graduated. Am I eligible? Yeah, I'm not. So we originally had this as a requirement that you had to graduate within a certain number of years. And that's still something I take into account. But from kind of looking at the stats of how people have progressed, the thing that seems relevant is how well you did when you originally did your course. So, if you've got a first in every unit, that's going to give me more confidence than if you just got a 2-1 in the relevant units. And does your job, let's say it has been 5-10 years, does your job is it likely to have kept up the skills? Have you been kind of doing things that will have maintained that knowledge? So if you're a manager mostly responsible for the finance aspect, but you used to be an engineer, probably not. But if you're still doing engineering calcs, then you're likely to have maintained some of that knowledge and we'll pick it up fairly quickly. So don't worry too much about that. Get your application in and we can assess it. Have a master's degree in physics. Okay. Okay, that's a very specific question. I think what's best here is if you contact Craig and maybe he can respond, or maybe I can get in touch with you. In general, if your degree isn't in something like doesn't have the word electrical or something very equivalent in the title, you can't go direct to the MSc, but there is this alternative entry route that might be suitable. There are some absolute requirements. You're not going to be able to pass the course unless you've done something equivalent to engineering mathematics. On a physics course, you might have done enough. You have to have done circuit analysis. There's a couple of others. And I'd really need to look at that in detail. I'm not sure.
Sure. I'll pick that up, James, with Charles.
Yeah. So someone's saying, is the course duration 2.5 years? The absolute minimum is 2.5 years. Most people take more like a year for their dissertation component, so it ends up being 3. Some people will take breaks if they've got a long holiday coming up, or a big work project, or things are getting a bit much for them, they'll only study 3 units 1 year, and that pushes it out a bit further. So there's flexibility there. But yeah, the minimum is 2.5 years. Yeah, okay. So if you've got the qualifications, someone's asking, I've got the qualifications, but I haven't been in industry. This is why I say I'll take industry qualifications into account. If you'd been, I don't know, working, planning outages for as part of the system operator for a country, then that's certainly going to strengthen your application. But equally, if you have really good grades from your university and your units were related and relevant to the course, so they were around power systems rather than, say, communication engineering or mechanical engineering, if you've got really good grades in electrical, then definitely apply. And electrical power systems, yeah.
Okay. Yeah.
Good. Okay. I think the questions are starting to go a bit quieter. Anyone else want to ask any more?
Oh, here's another one from Alistair.
Yeah. Okay. So how often are the taught lessons? So maybe I'll just jump back to. No. Sure. Okay. I'll leave it on this one. The most of the material is what we call asynchronous, so you can do it in your own time. So there will be a whole handful of recorded lectures, practice problems, discussion activities, quizzes, recommended sort of reading, assigned reading from the online textbooks. All of that stuff you can do whenever you want. So some people do it on weekends, some people, for some sort of industry sponsored students, they'll have a day or a half day a week where they do some of their work. Some people prefer to do weekends. Just as long as you think you can fit 15 hours in somewhere, that's okay. I don't mind. There are deadlines which you have to hit, but as long as you can kind of meet those. The only real synchronous stuff, the stuff you have to be kind of there at a particular time to get live, is these video conferences. I'll normally have a chat with whatever kind of cohort I've got coming in and say when's a good time. Generally, we do 5:30 to 6:30 p.m. UK time, because that's tended to work for all the different time zones that people are in, and people in the UK can often do things just after work. So you don't absolutely have to attend. We've got a number of people who work in control centers and do shift work. And so all of those are recorded so that you can watch them back later. And trying to think, there are deadlines which are at a particular time, but you can just work on them, a few days before if you don't have time, if you're not able to work on it days before.
Yeah.
How we work on the project. Okay, so this question's talking about projects and working at a distance. So there are 2 types of projects that we'll run. One is kind of based around your job and on the equipment and access you have to that. So it could be, try to think of an example, testing the performance of a transformer. That is something you do as part of your role anyway. You're just extending that or researching it and writing it up more formally as a master's project. So there, the equipment is stuff that you have access to as part of your role. The other one that probably makes up the majority of the work is something simulation-based or online. So there, maybe it's, so let's think of some of the recent projects. We've got someone looking at how distribution networks that have got a lot of wind power in, interact with protection systems because they think there's going to be some weird interactions with those. I think there probably will be. There's another person looking at modeling HVDC links and saying, well, what happens in if there's a lot of distributed energy, so again, a high rate of change of frequency and high voltage DC. So those are model a particular component. Someone else trying to work out the financial value of inertia. Someone else trying to work out kind of plan for digital substations, more of a literature review aspect. So there's a load of projects that you can run through access to software or through kind of data and research and analysis without having a physical piece of kit. Okay, so questions still coming through. Are the course fees yearly or one-off payments? There's a few different payment schemes. There is certainly a yearly one. The fees that I wrote here are the total fees, so that would be split over the 3 years that you'd be on the courses.
Yeah. Just to add to that, James, sorry, I spoke to somebody in our finance department recently. It was a similar question asked, and so if you are looking to pay in instalments, and as James said, you can make 3 instalments per year of your course. Obviously, if you were looking to try and complete this in 2.5 years, in the final section of your studies, you would make a number of payments in that shorter period. But generally, it's 3 instalments per year of study.
We have had some companies who just say, look, I want to pay this off this financial year. And I know that you can pay in larger installments, but yeah, many people pay in these 3 installments per year. How many students are assigned per tutor? So that varies depending on the number of people on the course. At the moment, there's about 30 people generally for each of the taught units, and there'll be the primary tutor, someone like myself, and then in some of the bigger units, you'll also get a graduate teaching assistant, so someone like a PhD student in the area who will be able to help out with some of the questions.
Okay.
Yeah. Okay. I think that might be the end of the questions. If you want to send anything, please do it now. But if not, I think that might be the end. Thank you, everyone, for attending.
Thanks, everybody. And just to finish from my point, James, is I will share the recording of James's presentation and the slides across to everybody. So if you need to go back to some of James's information that he gave you, I'll send that out later today.
Brilliant. Thanks, everyone. Hope to see you on the course.